All right, we're ready here. I'm starting right off with new vocabulary. Maybe some you heard, maybe some you have not. I got a formula for you today. There's some formulas in this unit as well. So let's start off. Let's talk about the just circle in general. All year long, we've been dealing with a ton of triangles. And if I asked you to name this triangle, everyone would say ABC or some type of combination of it. Why do you pick those letters? Because they're the what? They're the vertices, and that's how I name any figure, whether it's a triangle, quadrilateral, or anything above that. Well, I got a problem now, don't I? Circle, yeah, no vertices. So how do I name it? Here you go. First fact about a circle. We name a circle by its center. All right, a circle is named by its center. All right, by its center. So I want to introduce everyone to circle C. There you go. This is circle C. A circle is named by its center. All right, there are a couple parts I drew inside this circle. I think 2 out of the 3 you're aware of. Maybe some of you are aware of the third. Let's start with this line segment inside a circle. One endpoint is the center. The other endpoint is somewhere on the circle. This line segment right here. One endpoint's the center, one endpoint's on the circle. That is the radius. I figured many of you would know that one. One endpoint's got to be the center, though, for it to be a radius. All right, let's talk about this longer segment I have drawn in. One endpoint's on the circle. Another endpoint's on the circle, and it must pass through the center. Must pass through the center. That's a diameter. I figured everyone would know those two. And anybody want to drop a little knowledge? What's the relationship between the diameter and the radius as far as their lengths go? Radius, half the diameter, or if you want to go in reverse, diameter is double the radius. Again, though, for it to be a diameter, it's got to go through the center. Got to go. And then I have this segment. Endpoints are still on the circle, but this one doesn't go through the center. Does not go through the center. Anybody have heard of that term before? No? I had a feeling. That's fine. Chord. That is a chord. C-H-O-R-D. That is a chord. Could it go through the center? Yes. As long as the 2 endpoints are on the circle. A diameter is a type of chord. Why? Endpoints are on the circle. Is a radius a type of chord? No. Only one endpoint's on. If both endpoints are on the circle, we can call it a chord. If it goes through the center, we just up it and call it a diameter. Everyone good? All right, let me bring up this word, perimeter. What do you think about when you hear the term perimeter? Okay, me too. We've never heard that word, I guess, right? Let me do the English version of it. Perimeter. Has anybody heard of the word perimeter? When you find the perimeter of an object, what do? Add up all the sides, right? You add up all the sides. Got a problem? There are no sides. So we don't call this perimeter. And this is the topic for today. If you want to find the distance around a circle, distance, I don't use perimeter because it doesn't have any sides. We use what's called circumference. Okay, that's the distance around the outside of a circle, aka the perimeter, if you want to think of it that way. And here's your first formula of the unit, one of many to come. The circumference of a circle. You can use one of 2. Circumference equals pi times d. Anybody? D, we just discussed. That is the diameter length. Yes, I plug in the diameter length. If you don't like that one, no problem. I got a second version for you if you want to use this one. Circumference equals 2 pi r. And shocker, what do you think the r is? Radius length, yes. So you choose. I don't care which one you use. For class purposes, I'm always going to use c equals pi d. Why am I going to use that one? Because I can always remember that one as, ready? coffee pie donuts. Coffee pie donuts. You see it? C, coffee, pie, pie. D for donuts. That's how I remember the formula. Coffee pie donuts. You'll use it on the quiz next week. You're welcome. But you can choose. I'm going to use C equals pi d for class purposes. All right, find the circumference of each circle. Before we do that, though, interesting directions here. Leave your answer in terms of pi. So what am I asking for there? Here's what I'm asking. At the end of your answer, pi should still be there. I don't want you to go, relax. I don't want you to go to your calculator and use the pi button. Just keep bringing it down into your final answer. That's what in terms of pi means. Have an answer that has pi in it. Okay? So here we go. C equals pi d. I'll be using that one. If anybody wants to use the 2 pi r, feel free. Pi stays pi. That's a number, 3.14, da-da-da-da. What's the 16 referring to in my diagram? What did we just call that, 9? That's the radius. The radius is 16, but in my formula, I need the diameter. So what would you like to do to the 16? 16. Oh! Double it. So I end up with 32. And I don't want you to go to your calculator. Leave it in terms of pi. You could leave it like this, but do you say x4 or 4x? You say 4x, right? So why don't we say 32 pi? All right. That is in terms of pi right here. Leave the pi in your answer. No need to go to your calculator. All right, so rest of the class today, different ways I can use circumference. All right, 2, find me the diameter and radius if I give you the circumference. So going backwards now. I gave you the radius in problem number 1. Now I want the radius if you know the circumference. So start out, C equals pi d. Where's that 106.4 going to go? 2?
And the circumference?
Circumference, 106.4 equals pi d. Now I need to solve for d. Don't get freaked out. Pi is just a number. Just a number written as that symbol. So how can I get rid of it now to get d by itself? 19? Divide both sides by pi. Perfect. Now, yep, I'm already getting it here. Pi is located on the left-hand side of your calculator. It's right above the caret button, I believe. So I think you have to go second caret, many of you, and get that pi symbol there. There's where it's located on the calc. Everyone locate it? We're good? Okay. Nearest hundredth, rounding directions, nearest hundredth. How about that diameter? Oh, 11 ones. What do you got?
3.87. 33.87, my bad.
It is your bad. 33.87. And we also have another bone to pick there, Brody. You ever write obviously on your test again instead of like in conclusion? Like look at me, big man. Of course it is because I'm saying it. I'm writing it. Yeah. Okay. I wanted to write something, but I refrained from it. A couple of you in this group think you're big heads over here now. Yep. Instead of thus or ergo or therefore. Obviously. Do you know? Look at the name on the front of the paper. Don't you know who I am? Okay. Everyone's good. 33.87. Sorry, just had to vent there. Now let's go to radius. You know what I'm saying there, Emma?
Yep.
Yeah, I know.
I wrote it in front of you.
Yeah, sure. Radius. I get it. Divide by 2. What's going to be a more exact answer? Dividing your rounded answer by 2 or the number hopefully you still have on your calculator by 2? Calculator, yes. So make sure if you're dividing or maybe multiplying by 2, you use the answer in your calculator, not the rounded answer. We use a more exact answer. So dividing your calculator by 2, 12, radius, 16.93. All good? Any issues? All right, let's keep grinding. No pressure here, but period 7 remembered this term that's coming up here. No pressure. A square with a side length of 9 is inscribed? No? John?
These are circles inside.
Okay, whoa. Yes and no. So there's my circle. Let's get a square going here. It is inside, but that's not inscribed. What's got to happen? Vertices have to touch it. Correct. All right, so here we go. I got the square inscribed in the circle, so the vertices must be touching. And remember, it's a square. It is a square. Hopefully, we remember some properties of a square. One side is 9. What's the exact circumference? And directions here. Exact circumference, fancy way of saying leave your answer in terms of pi. No rounding, no calculator display. Leave it in terms of pi. I think you'll see that on the assignment tonight. Hey, let's go. Remind me of the formula. What's the circumference formula? 12, again. Pi times diameter. That's not a bad formula because the only thing you need is the diameter. You know the diameter, you know the circumference. All right, so let's talk here. Let's see if we can come up with a solution. How can I find the diameter of that circle just knowing one side of the square is 9? All right, let me do some drawings here. Maybe it'll help us out. The diameter I did here, right there, look like this. Okay, can I find the length of that diameter? I'm pretty confident from here to here is 9, but what about the other 2? Are they congruent? I don't know. How can I find it? I give up. I'm not going to find that diameter. And if anybody has a suggestion, let me know. I'll give you the pen and you can take over the rest of the class. I have no idea how you find that diameter. All right, so can I draw? There's infinite diameters in a circle. How about this one? Can we find the length of that one? I run into the same problem, right? I don't know the edges there. So that's not going to work. Darn it! Is there any diameter you can help me draw in that maybe I have a shot at finding? Because the vertical and the horizontal one weren't cutting it. Is there one you could maybe help me draw in and say, you may not know how to find it, but we got a shot in finding it? What do you got? Diagonal of the square. All right? Diagonal of the square is also the diameter of a circle. Great job. Now I need your help finding it. Now you got to dig deep previous units. What do you know about a square? All angles are 90, so I can throw a little 90-degree angle right here. What else do you know about a square? I'm not done filling in my square yet. I got one more thing to write. All sides congruent. So if one side's 9, this side's 9. Looking for my diameter. What can I use here to help me? Pythag. I can use Pythag. Or if some of you are really on top of your game and want to show off, Pythag's great. This is a 45, 45, 90, isn't it? All right, because these are congruent. This is actually a 45, 45, 90. Yes. So either way, if you remember the rules, though, right? How do you find the hypotenuse of the 40? I gotta look back at my notes. All right, then do Pythag. All right, which I'm going to do right now. I just want to get a little more practice in breaking down radicals. 9 squared equals c squared. $81. And look, if anybody remembers the rules, go find it now. That's fine with me. Use your 45, 45, 90 rules. If you don't remember the rule, I guess we're going to have to use Pythag. 81 and 81, 162. Equals c squared. Break it down. You've been in this class long enough this year. I don't care about the decimal your calculator is giving you back. We break down radicals in here. So we need to look for the biggest perfect square that goes into $1.62. Everyone gets 4, 9, 16, 25. They keep typing and typing and typing. It's already on your paper. Look at the line, a couple lines before. What do you see there? 81 twice, huh? And 81, I believe, last time I checked, was a perfect square. 81 times 2. So what ends up being the, whether you did your 45, 45, 90 rule, got there quicker than we did, or Pythag, what is the length of that diameter? 6! It would be. And there's my diameter. So C equals diameter 9 radical 2 times pi. I just asked, make sure that pi is clearly outside the radical, right? All right, questions? I'm going to make you think on this next one here. I'll give you the center, and I'll also tell you a point the circle goes through. Can you help me find the diameter knowing that? Well, just reading that doesn't tell us anything. Can we get a little visual here, maybe, of what we're working with? I think once you see the visual, be like, oh. Maybe not. I don't know. 3, -2. 1, 2, 3, negative. Whoa, easy. Point Q. 1, 2, 3, 4, 5, 6, 7, 1. It's point R. Ready? Diameter. Just given Q's the center. The circle goes through R. Let me help you. If you're not seeing it yet, ready? Let me actually show you what this circle looks like. And you can freehand this. I don't want you to get your compass out. Here you go. This is what you wanted to do all your life with your compass. Ooh, go all the way around. Ooh, now I see it. How does QR help me here? If you need even more, Q to R. What did I just draw in there from Q to R? 21?
The radius.
And what's that relationship between the radius to get to the diameter?
Radius is half of the diameter.
Yeah. So if I could find the length of QR, I'm going to double it. Wait a second. How do I find the length of QR then? You've been in here months. 6? Oh, I love it. Yes, on a Friday. Why not? Why not? Yeah. It's always going to be a good day when the distance formula gets busted out. Party Central, everybody. The distance. Whew. Go ahead. Find the distance then. If you haven't already. Go ahead. Find your distance. Should be no reason to break down this radical. I don't know why I'm doing this all out. So many unnecessary steps, but here you go. Diameter 5, radius 5. 28 diameter.
10.
How'd you get that?
2 times 5.
Because you can multiply. Good. And then you have one more that you will be doing in your group. And yes, you can assume that's a rectangle.
Oh, circumference.
I was like, Sam, how do you know? And he's like, oh, you are. I was like, it goes for like a minute. Yeah. Sam sits down on his computer and looks at pi and just moves all
You look super hard and you really be stuck in your house.
It's 3.
That's what you do on Saturday.
Oh,
That's crazy.
I think that's possible.
oh, I just did the answer.
That's outrageous.
Should do Pythag to find the diameter. Pythag gives you the diameter length of 10. Plug it into the formula, leave it in terms of pi. Pi should be in your answer. Circumference 10 pi. Before you break here to grab a textbook or start the assignment, just a heads up. Every year we relook what we assign for homework, and some years we add to it, some years we deleted it. So I just wanted to give you a heads up on some of the answer keys this unit. You may see extra questions, all right, that I didn't assign. I don't expect you to. You do what's on the bottom of the packet. Okay, you'll see the answers you need, but if you see extra answers, okay, so be it. Just ignore it, please. All right, and I'm going to put those answers up on the board, so there is no excuse I can't check my answers. All right, so let's go. Let's get to it. You play your cards right, probably won't have any homework over the weekend.